In mathematics, a monomial is, roughly speaking, a polynomial which has only one term. Two different definitions of a monomial may be encountered. For the first definition, a monomial is a product of powers of variables with non-negative integer exponents, or, in other words, a product of variables, possibly with repetitions. The constant 1 is a monomial, being equal to the empty product and xo for any variable x. If only a single variable x is considered, this means that a monomial is either 1 or a power xn of x, with n a positive integer. If several variables are considered, say, then each can be given an exponent, so that any monomial is of the form with non-negative integers. For the second definition, a monomial is a monomial in the first sense multiplied by a non-zero constant, called the coefficient of the monomial. A monomial in the first sense is also a monomial in the second sense, because the multiplication by 1 is allowed. For example, in this interpretation and are monomials. In the context of Laurent polynomials and Laurent series, the exponents of a monomial may be negative, and in the context of Poisson series, the exponents may be rational numbers. Since the word polynomial comes from poly plus the Greek word I1/2 I1/4 IOI, a monomial should theoretically be called a mononomial. Monomial is a syncope of mononomial. Comparison of the two definitions. With either definition, the set of monomials is a subset of all polynomials that is closed under multiplication. Both uses of this notion can be found, and in many cases the distinction is simply ignored. See for instance examples for the first and second meaning, and an unclear definition. In informal discussions the distinction is seldom important, and tendency is towards the broader second meaning. When studying the structure of polynomials however, one often definitely needs a notion with the first meaning. This is for instance the case when considering a monomial basis of a polynomial ring, or a monomial ordering of that basis. An argument in favor of the first meaning is also that no obvious other notion is available to designate these values, while the notion term of a polynomial unambiguously coincides with the second meaning of monomial. The remainder of this article assumes the first meaning of monomial. As basis, the most obvious fact about monomials is that any polynomial is a linear combination of them, so they form a basis of the vector space of all polynomials, a fact of constant implicit use in mathematics. Number. The number of monomials of degree d in n variables is the number of multi-combinations of d elements chosen among the n variables, which is given by the multi-zit coefficient. This expression can also be given in the form of a binomial coefficient, as a polynomial expression in d, or using a rising factorial power of d plus 1. The latter forms are particularly useful when one fixes the number of variables and lets the degree vary. From these expressions one sees that for fixed n, the number of monomials of degree d is a polynomial expression in d of degree with leading coefficient. For example, the number of monomials in 3 variables of degree d is. These numbers form the sequence 1, 3, 6, 10, 15 of triangular numbers. The Hilbert series is a compact way to express the number of monomials of a given degree. The number of monomials of degree d in n variables is the coefficient of degree d of the formal power series expansion of. Notation. Notation for monomials is constantly required in fields like partial differential equations. If the variables being used form an indexed family like, then multi-index notation is helpful. If we write, we can define and save a great deal of space. Degree. The degree of a monomial is defined as the sum of all the exponents of the variables, including the implicit exponents of 1 for the variables which appear without exponent. For example, in the example of the previous section, the degree is. The degree of is 1 plus 1 plus 2 equals 4. The degree of a non-zero constant is 0. For example, the degree of -7 is 0. The degree of a monomial is sometimes called order, mainly in the context of series. It is also called total degree when it is needed to distinguish it from the degree in one of the variables. Monomial degree is fundamental to the theory of univariate and multivariate polynomials. Explicitly, it is used to define the degree of a polynomial and the notion of homogeneous polynomial, as well as for graded monomial orderings used in formulating and computing gra-paragraph BNER bases. Implicitly, it is used in grouping the terms of a Taylor series in several variables. Geometry. In algebraic geometry, the varieties defined by monomial equations for some set of I plus or minus have special properties of homogeneity. This can be phrased in the language of algebraic groups, in terms of the existence of a group action of an algebraic torus. This area is studied under the name of torus embeddings. See also, monomial representation, monomial matrix, homogeneous polynomial, homogeneous function, multilinear form, log-log plot, power law, notes.